For this first problem, I'm going to show you the skill piece one more time, but then we're going to actually do the rest with dominant terms if we can. So again, what I'm looking for in the denominator is the highest power of x, and that is the x squared right here. And again, I'm going to ignore this 3 because it doesn't really matter so much, but we're going to do the limit as x approaches infinity of a 2x divided by that x squared plus 5 divided by x squared over 3x squared divided by x squared plus 1 over x squared. If we look at each piece separately and simplify them, we have the limit as x approaches infinity. 2x divided by an x squared is 2 divided by x, plus then I'll have a 5 over x squared because I can't simplify that individual term, divided by 3x squared over x squared, which is just a 3, plus 1 over x squared. Now notice what this actually does. When you pick the highest power of x in the denominator and you divide by it, you're guaranteeing that you will actually have an integer in your denominator. And every other term will be divided by an x power that's higher than what it started with because we'll have picked the highest. This is x to the 0. I'm dividing by an x squared. You will always have an x in the denominator of those terms, which means that this, as we know, will actually go to 0 when we take the limit. So you're dividing by a number. And what that gives you is, not an indeterminate form. You're not going to get infinity over infinity. You're going to get something divided by a number. So when I plug in infinity now, I have 2 divided by infinity. 2 divided by something huge is small, it's going to 0. 5 divided by an infinity squared is small, it's going to 0. And I have 0 plus 0, which equals 0, divided by 3 plus 0, which is 3, and 0 divided by 3 is equal to 0. So this limit is 0. Now if I take a look, what if I had been doing the limit as x approaches negative infinity? I'm looking on the left-hand side of the graph. This would still be going to 0. It would be 2 divided by a negative infinity. 2 divided by something huge would be headed towards 0, but the sign would be negative. Here, the negative infinity squared would be a positive infinity, so we're still at 0. The 3 is still there, and then again we have a negative infinity squared. It's a positive infinity. 1 divided by something huge is 0. So either way, we're getting 0 as the answer. So I know that y equals 0 is my horizontal asymptote. Now if I look at dominant terms, the dominant term in my numerator is the one with the highest power of x, the full term, and that is the 2x. The dominant term in my denominator is a 3x squared. I'm ignoring the 1 because this is 1x to the 0, this is a 5x to the 0. I'm looking for the highest power. So if I take the limit of that, and I can actually do it with the negative infinity or the positive infinity, so let's say 2x over 3x squared, and I simplify it, that's the limit as x approaches negative infinity of 2 divided by 3x. I'm not changing my answer. 3 times a negative infinity is negative infinity. 2 divided by something huge, whether it's positive or negative, it still goes to 0. So if I plug in a positive infinity here, I get 0. If I plug in a negative infinity here, I get 0. And I actually knew that from the beginning of the problem, because if you come look at this, there are more x's in the denominator than in the numerator. If I think about dominant terms comparing the numerator to the denominator, 3x squared is quadratic, 2x is linear. 3x squared is greater, it has a higher power of x than this, so I'm going to be left with infinity in the denominator for this problem. If you think about it graphically, I'm looking, let's say we're doing the limit as x approaches infinity, I'm looking on the right hand side. Say that this was, and I'm only looking at the dominant term, so say this was 2x, y equals 2x. It is headed towards infinity. If I look at y equals 3x squared, that's quadratic. It's also headed towards infinity, but it'll be greater in value than this one. So if I have something that's big divided by small, I'm going to actually get my infinity there. So you can do dominant terms with the algebra. You can actually stop and think about it. If you have a higher power of x in the denominator and you're looking at a polynomial divided by a polynomial, you're looking at y equals 0 as a horizontal asymptote. Okay, for this next problem, I changed it a little bit. I don't have a higher power in the denominator. My powers actually match. So I am going to do dominant terms. I look in my numerator. The highest power of x, the term with that is 2x squared. In my denominator, it's 3x squared. So I'm going to do the limit as x approaches infinity of 2x squared divided by 3x squared. And if you look right now, my x's actually cancel out. So I'm doing the limit as x approaches infinity of 2/3, which equals 2/3. If I do the limit as x approaches negative infinity, my x squared still cancel out and I still have 2/3. So this problem only has one asymptote, y equals 2/3. If I look at this problem, when I see that I have equal powers on the x, I know that I'm actually going to get a number that's not 0 as an asymptote. Okay, one more problem related to these. I have y equals 2x cubed plus 5 divided by 3x squared plus 1. If I look, I have a higher power of x in my numerator now. So when I pick my dominant terms and look at those, the limit as x approaches infinity of 2x cubed divided by 3x squared, my x's don't completely cancel out. Some of them do. So I know that this is actually the same thing as the limit as x approaches infinity of 2x over 3. Two of the x's canceled out in the numerator and denominator. If I look at my problem now, as x approaches infinity, 2 times infinity is infinity divided by 3 is still pretty huge, so this is actually headed towards infinity. If I look at as the limit as x approaches negative infinity, to the left of the graph of 2 times x divided by 3, that will be negative infinity. So my graph is not leveling out. It's headed up to the right and down when you go to the left, so there is no horizontal asymptote. You actually have to get a number for your limit to get a horizontal asymptote. Let me give you an example of what's going on here. Something very basic. Y equals x cubed divided by x squared. Okay, the power in the x is greater. There's going to be an x left over if I reduce this. So I'm left with, in fact, just y equals x. Now, these two graphs are not the same. Okay, this is y equals x. This is what we know, y equals x right here. This graph actually has a discontinuity when x equals 0 because you cannot have a 0 in the denominator. You cannot divide by 0. So this graph is actually this one right here. They look the same, but this one has a removable discontinuity. You'll notice that neither has a horizontal asymptote. If we had an x to the 5th divided by an x to the 3rd, it would look quadratic in nature. You might actually have some vertical asymptotes that come in there when you start adding other terms. But no horizontal asymptotes if the power in the numerator is higher than the power in the denominator.